Hello, a very good afternoon to you all, and welcome to Epsilon 2022. I'm Parvati Nair, the Joint Secretary at IEEE SIESGST.
And hello everyone, myself Ankur Rai, the Technical Head at IEEE SIESGST. We are honored to be your host for the second edition of our flagship event, Epsilon 2022, wherein our main goal is to provide an organized learning atmosphere and share technical information surrounding the theme, the Internet spectrum.
We hope the preceding two sessions under the IEEE and the CS track provided you with a significant amount of information. Now it's time for the final session of the day under the MTT-S track, an introduction to 5G and IoT, which is titled as Elementary of 5G and IoT.
So, before we begin, I'd like to provide some information for the attendees. The exercises and quizzes we have provided for each day of our symposium will put the participants' understanding of the topic covered in each session to test. Each action is worth a set number of points, and player will be graded based on them in order to compete on the scoreboard. And by the end, every participant will receive a certificate, and the top score will get exciting goodies. So let's begin our most eagerly awaited session by introducing the speaker. So today we have with us Mr. Vinod Shrimali, who has 7 years of expertise in the IoT, telecom, signaling, and IT infrastructure sectors and is presently employed as a telecom security specialist for one of the largest telecoms in the MENA area. Additionally, he has in-depth knowledge of next-gen cybersecurity methods, including red teaming and shadow IT.
Also, for the attendees' information, this session will go on for 90 minutes prior to the quiz session, and we will send a link to the quiz in the chat box during the final 15 minutes of the session. Hello, sir.
Yeah, hello.
Hello, sir. We are thrilled to have you here and are looking forward to this really incredible session.
So,
Oh,
without
great.
further ado, let's begin the session, and we would like Mr. Vinod Shrimali to take over and address the audience.
Oh, thank you so much for inviting me, and I really glad to be a part of your this graduating program. And first of all, I would like to thank you for inviting me to take a part into the revolution inside the telecom industry, which is going to be 5G and upcoming technology. Thank you so much for inviting me. So let's have starting our session. Let me share my screen.
Yes, sure, sir.
I hope it will be visible for everyone. Yeah.
Yes.
Yes, sir.
Okay, great. So I think you have already introduced everyone that we are going to be start with our first day, that is like elementary of the 5G and IoT, in which the main agenda behind this presentation is to discuss how a 5G is making a revolutionary changes inside industries, best practices, and upcoming industry, as well as how IoT will play a major role and what will be the support from 5G to create and enhancing our life and day-to-day activity by increasing the capacities and support for the IoT side. um, so let's starting with the very basic things. Just like to introduce myself. Currently working as a telecom security engineer, and current area of expertise from my side is the 5G and 6G right now. And but yeah, from the startings like till 2017, I have worked with the signaling and GPRS security, which is like lazily on the legacy technologies, mostly like 2G, 3Gs and all. After the 2019, I changed my track mostly from the upcoming technology like 4G LTE, Volte, and now after 2019, I moved towards the 5G. Then the Volte is the main part of the testing, and most probably we will definitely change to the 6G, which will be the upcoming technology for that. So And I also like to tell everyone that as of currently I'm also associate member for the GSMA, which is like the organization for telecoms security. The content which we are going to cover today, most probably the introduction for the 5G and IoT security, how IoT security and what is the role of 5G inside the IoT security part. Then what we are going to be covered is like building of the from the 1G to the 5G, like how the technology and the revolutions come day by day, and how we are reaching to the 5G, and how faster the growth will come, what are the component will be include, and how it will open opportunity for upcoming market and the futures. Okay, and then couple of the key component and the security element inside the 5G and IoT part, and like how the 5G will impact the industries, different part of the industries era, and the IoTs, like how it can help us inside a medical, inside the logistic part, and also these are like four main component which we are going to be discuss. So let's start with the first one, which we like introduction to the 5G. So now, as of now, we all have. Is it visible here? Hello.
Yes, sir.
Okay, sorry. Okay, so as of now, we all know that like we are using internet in our day-to-day life. I suddenly like how the internet charges are going low in India, and we are using the internet for day-to-day life. But the some one thing come to our mind, like how this internet will impacting the commercial life, and how it will make impact on our day-to-day life and current infrastructure. So recently, the latest technology we all guys are using is the 4G, but like there are some couple of the drawbacks we have with the 4G. Like for example, no, there are a couple of the challenges we are facing in terms of business. As I would like to say initially, the 4G provides us a very good platform. Like we are getting the faster data speed, reliable connection, real-time connectivity. Okay, but still there are a couple of the limitations we have in terms of the business. Like there is an issue with the productivity hamper. Also inside the background, we have very complex hardware. The connectivity is still limited inside the 4G. Okay, there sometimes we are facing the communication issues like the cross connection of the calls. Okay, as well as like there are a couple of the glitches and no bugs we have. If in case in terms of IoT, if we talk about, then yes, there are a couple of the glitch we have. There are very poor battery life we have. Still, the communication is not reliable, and there is lack of a dedicated function. And the more thing is like they are not reliable. Like we cannot trust on a complete 4G network. Like still, you need a backend connectivity, either a LAN or something. And just to draw back those things, or again, yeah, speed is the major problem, because when you want to do something on the real time, or let's suppose you want a very low latencies or very low jitter, you really need a very good speed. So how to solve this one? Now to solve this one, of course, there was a new solutions and the new revolutions come into the market in the telecom companies and telecom industry, that is called 5G. This is like so fifth generation mobile, which like giving you the very good speed. For example, the latest test which we have done like long back ago, where we are getting up to like 620 Mbps in a wireless, which is like again a very small test we have conducted. But our target is to achieve the 1 Gbps speed and more than this one inside a 5G. And then we are planning to move from 5G to 6G, where we can get the speed of 1000 Gbps. And just to solve all those things, we have introduced a new concept called fifth generation cellular technology. So, like we are starting from the first generation to the fourth generation, and now from that we are moving enhanced. And it's take a couple of years for this revolution coming from the first to the fourth generation. And after that, this revolution is like exponentially growing, because it will take huge changes. For example, if we start to 3GPP has already initiated like this fifth generation radio, which is also known as the 5G NR or fifth generation new radio, which will defining all the properties, the connectivity part from the 5G, from the user interface side or the RAN side. Okay, the first definition of the 5G what come from the release by the 3GPP. This is an organization which is taken care of all these regulations and the definitions and the documentation available for the upcoming technology, which first definition was available in 2018. And after that, there was a couple of the changes has been made on the no existing documentation. And the current documentation from 3GPP is the 3GPP release 18, which is like released by 2020, which we are following it right now, which is contain all the specifications, the definitions, and the parameter which is part of the 5G. Now, the major thing which I told, why 5G was required, correct? Because like we already have a 4G, we are already getting the good speed. Then what was the main concern that we are introducing to the 5G? As you know that no, our demand is growing day by day. Correct, we are, the technology is growing, we are living into the modern societies, our society is getting smarter, and like we are living a real time data where like a millisecond of delay will not even be considered, and just for no just for fulfilling such requirements and delivering the fast capacity with a very low latencies, and the internet connection should be fine, we come to the 5G. So if we talk about the 5G, like the 5G latency, if you talk about the latency, the 5G latency is just a 1 millisecond, as low as, because initially when we was in 3G, you see the connection was very slow. If we want to do a real time task, it won't possible because there was at least 100 millisecond latency was there because the response was very slow. And then the researcher come into the new concept and they introduce the 4G where we like reduce the latency to 3 milliseconds or 30 milliseconds. But again, the issue was there, still 30 millisecond is very big latency, and just for that we come to the new technology which is making a full revolution to a market, that is called 5G. Inside we are getting almost a 1 millisecond latency because you will get the response as fast as possible. So now the question comes, like when we're talking about the 5G, how it look more different, what are the element including inside the 5G, what are the like components, how the internal architecture will look like in this one. So basically when we talk about any telecom industries, any telecommunication standard, it will be like derived from the different things. For example, you will have your user equipment, then you have a radio access part which is like RAN part, and then you will have your core part. So this is like how you're dividing into the infrastructure. User part is like your user equipment, your mobile laptop connections, which is we are using for accessing the internet. Then there is a radio part which is allow us to be connect. This will be like your base stations, your e-node Bs, and then there is a backend part. Backend part basically the core where all the terms and all the architecture we have to serve your request. We will discuss the architecture in the later slide, but in general way, the core is the part where which can handling all the data, all the signals, every communication from your side inside the backend, and then it will be served to you. For example, I want to access internet, so I simply just use my phone and I just type google.com or something, but there is a lots of process in the background, like my user registrations will be there, how I'm using the internet, what speed should allow to me. This all decision should be taken care by a code part. uh, so you can see that the major changes what 5G is impacting us. Basically you can see the in this diagram there is like 4G versus 5G. So in 4G the structure was a little bit complex, we are always required independent hardwares, and the protocol is the main thing because like they use a signaling protocol, for example diameter protocol, which is communicating with each 4G stack either is a. But in a 5G what we have done is, since we are our main goal is to reduce the latency and moving towards a new infrastructure and just terminate or eliminate all the dependencies what we was having in the legacy technology. So here what we have done is we have used IT technology. This IT technology will be like, for example, we are using the JSON based APIs, we are using the HTTP protocols, we will use normal TCP IP protocol suite for connecting the 5G component, and all the communication inside the component will be taken care by a HTTP2 and a JSON API. So you don't need any specific signaling protocol. You don't need to design any signaling architecture for this one. So now, if we talk about the front-end architecture, basically, they will be also containing some microcells or small cells base station. Okay, like this is how we are having inside a 4G. You can see the big towers, which was we are having in the 4G. There was a big towers, correct? These towers is basically your BTS or maybe your e-node Bs, which is allow you to connect your phone via radio signals. Now inside the 5G, we will use the microcells or small base station, so which will again like inside a limited area we can provide a bigger coverage. Then in the core part we will have the MECs, which will MEC will be there. We will discuss about the MEC and how MEC play a very huge role inside the IoT and to serve and provide the faster services. Then the second thing we'll be having is the 5G core, which is basically your core component to handle register the user interfaces, registering your mobile devices, providing the respective services, reducing the latencies, and your different data network which you want to use. So now the questions come here. In 5G, like no, we are using each country has their own different band. I think recently there was a bid in India happen, and lots of the people and players they have got their own spectrum. So it's like totally depend upon the spectrum, what spectrum you are going to be get there in which you are serving. Because now, how is making the revolution for you as compared to the 4G is like, no, you can set up your own private 5G network. For example, you have certain requirement, you don't need the bigger network. You can set up your small network based on the requirement. Like suppose example, you are having the shipping industries and you want to logistics shipping industry. So you can set up your own small network where you can just connect particular IoT devices and IoT devices, connect your 5G equipments, and we can serve as your private network. So you don't need to be connect outside, you don't need to be connect with the real world. And this is the way how you're reducing the latency, because let's suppose you want to do a task X, you are only assign a network for a task X. You don't need to be connect with this couple of network which will doing all the different tasks. So if you can see how the 5G infrastructure will look like, so you can see the couple of the components will be here. And the basic advantage what we are getting is inside of 5G, because we are using the NFVI, that will be the network functions, and we are using the software defined networks. You don't need the actual physical boxes there. So all the functions will be virtualized, or it will be defined by a software system. So in the end-to-end architecture, if you can see here, we have like IoT systems, we have edge computing, we have our user systems, and these systems will be connected through a RAN network. RAN network is a radio access network. And most advantage things which will be having there will be your millimeter wave, because like this will be like very short distance wave you will be having there and providing the big coverage. Now if you go more, then you have different for example, if you go apart from the radio network, so you can see in a radio network you have many things like you have millimeters wave, you have your G node Bs, and these systems are connecting through a centralized RAN or your transport network. Transport network basically your core network where you are serving each of the component based on the requirement. For example, if I have a connected cars, or if I have mobile devices, if I have the IoTs, how will I serve them? Based on the request, I will have my different controllers which will serve to your infrastructure. And then you can see the backside is a data network, which is like based on the requirement, like each of the component where I will put inside my data centers. Yeah, for example, like 5G core system, AMF, SMF, those will be put inside a data system. And I will also create a slicing for that, so that way it will reduce the latency for me. Like if you move next, it will like more clear picture. So you can see we will have in upcoming technology we are going to be have a more advanced feature, because as you know this is more revolutions. You will have your user equipment, you will maybe have your connected services. Now we have a metaverse is the next thing is going to become. We have connected drones, smart cities. So those are things which will be connected to your, which will be connecting to your radio access site, correct? That radio access site, it might be a G node B, it node be a E node B. And then what will be happen is based on this connecting requirement or connecting component, you will be connect to a backend side. Backend side will be your 5G core. Inside a 5G core, there are a couple of the advanced technology which we are using it to, as I told you initially, we are going to put everything on SDN. Then we will use some NFVI functions, which will also reduce our dependency on the complex hardware. Since we are reducing our dependency on the complex hardware, we can create small pod or small virtualized or small virtual machines, which can help us to deploy small functions based on our requirement. Okay. Now, after that, you can see, like for example, once you are connecting with your network and you are connecting to a core, the 5G has couple of the functions there, which we are going to discuss in the coming slide. But just for discussion, I can see they have the something called AMF, SMF. These are the functions which is newly introduced inside a 5G. If we talk about the 4G, we already have some old traditional functions like MME, HSS, HDW, PGW, which are performing the traditional task. And since 5G has two different type of deployment, either we can use the standalone deployment or we can use non-standalone deployment. This totally based on the requirement how we are going to do this. We will discuss in the upcoming slide. And this end-to-end solutions which will help you. For example, in upcoming technology, we are going to have a smart logistic, agriculture flight, we have connected cars, or we are going to have a driverless car. So when we are saying is a driverless car, is more about the artificial intelligence and the real-time connectivity and monitoring of the car based on the command which I'm going to instruct, and this will be execute on a real time. If there is a latency, of course there may be chances of the accident, or there may be chances of some hazard. So to reduce this one, what we are going to send some real-time command, and that will be executed there. And more requirements coming, like we are going to have the smart city, that is a very popular concept nowadays, We are going to have smart factories which will be fully automated through robots and the automations part, which we are going to cover in upcoming slides. So why we are going towards a 5G and what are the advantage we are going to get from the 5G? First of all is like deep coverage. Why we need deep coverage? Because in 4G still there is very limited locations. For example, if you are going your ground floor or if you are going underground, you are not getting the towers, or maybe you are going to some remote area, there is a lack of towers. And since 5G, we establishing a cells, and this cells basically covering a whole area. So there may be the issue for the tower. You can see if you are going little bit far, you are not getting the proper towers inside your systems, inside your phone. Sometimes you are using a 4G, but still your speed is like working is as slow. Like for example, you are working in 2G only. So the main thing is a deeper coverage, which will be covering through a millimeters wave, which will be going to be covered through multiple small sites. So we are not going to create a big site. We are going to create a small cell which will be serve multiple users. Then the second thing which we are going to put is the strong security, because no, for example, since we know that the technology is going to be there is a revolution in the technology is going, like we are going to be connect our smart cities, we are going to be use a driverless car. So of course there is a lots of this huge security is required. Yes, because for example, tomorrow you are driving your driverless car and somebody who just put a small malware and then he is able to control your car. And that's the purpose what we are using. We are using the strong security inside the 5G, which 5G promise, because this is decomposing the physical infrastructure. You don't need to be have a dependency on the large hardware. You don't need to be have the dependency on specific no operating systems and all. And the second thing what happen is the all connected component are very scattered. For example, if I design one component, for example, if I create a slice which will only serve my car feature, so then if any operation regarding my connected car or any operation regarding my driverless car will be going to perform, this will only interact with a particular slice, or this is going to be only interact with particular component. It is not going to be interact with a different component, and that's the way we are providing the higher security in this one. Then the ultra high speed reliability, because as I told you, the latency in 5G is going to be just 1 millisecond. Sorry, just 1 millisecond. Therefore, the speed will be more higher. Like as I show initially, we are getting 6 Mbps in just small wireless test, which is going to be increased more. So if you have very higher speed, the rate of data transmission will be very high. And since the rate of data transmission will be high, you can perform a very fast real-time actions. So this is like, and you know what, this is like going to provide a huge changes inside the telecom. Then instead of mobile broadband, they are going to be reduce the speed from the Gbps, and inside the 6G we are, as I told initially, we are trying to achieve the speed of the terabyte. So it's going to be 60 Gbps. Okay, then with the more optimized networks, like you depend upon the requirement, and as I told you, they have two deployment model. Either you can use a private 5G, which is like for specific purpose, or you can use a dedicated 5G. And of course the NB-IoT system which are going to be used inside the 5G will be also having they will use very small energy, because the data transmission rate is high, as well as only the required data is provided. In this case, the energy, or as I say, as ultra low energy, it means the data transmission, based on the data transmission rate, the battery life of the component will be high, because nowadays if we are getting some NB-IoT component, their battery life is very low. I think they are having a 1 or 2 year, after that you need to change the battery. But let's suppose you are deploying some component into the remote area where you cannot go every time. Then based on the 5G requirement, what you can do, the battery life for the shelf component will be increased to the 10 years or more. So like these are the main advantage which 5G is giving, and this is the reason we are moving towards the 5G. Now, as discussed, like how the 5G will be deployed here. So as I told, there will be like virtualization system will be there. Okay. Now let's talk here. For example, nowadays we are only connecting our mobile phones, we are only connecting the laptops and other stuffs to the 4G network, and we are performing some internet exploring the internet, or performing the day-to-day task, or we have some NB-IoT component and all. But what about the SIM-based or real-time camera? So who will be the end user for 5G? 5G end user will be like the mobile phones which we are using. We may be using some smart cameras or the monitoring systems. There will be the connected cars. There will be the smart city component, and these all component will be connected to different cell site. For example, I can design one site which can handling my mobile mobile nodes. One side which will be handling the camera side. Okay, one side will be your connected cars. So these will be all connecting through a edge connectors, where you will have a, like, you don't need the bigger infrastructure. You will have the connected DU and CU, which is like part of the open range. So what happen is, inside, if you see, one, we can deploy one small cell, we can deploy a millimeter wave, which is just providing a radio connectivity, and after that it will be distributed into separate part. For example, one connectivity, I can there is two things you can see. There is a DU and CU. Basically it's a data unit and control unit. So what happen, I can create a slice and virtualization for the data unit, so distribution unit, sorry. So where what happen is, let's suppose I have a connected card which will be connecting with the one DU, and if I have cameras, mobile, and anything else which can connect to different DU, and this all will be connected through one centralized unit, which will like encrypting your traffic. And you can see, I don't need any physical hardware, or I don't need any complex hardware. I can just deploy one guest OS, and on top of that I can deploy different Kubernetes pod there. Now how this Kubernetes pod will help me, they basically help me. For example, if somebody perform let's suppose some mobile user perform attack and is going to shut down one particular DU, or when he is going to shut down particular pod, the Kubernetes will immediately replace this pod and it automatically restart the system. So therefore I am not attacking any other infrastructure, and not attacking any other system. Or some user who is trying to initiate a DOS attack to particular function, the other function will be just replace it, and therefore other component will not be disturbed, and we will getting the real time data, and everything will be available on the real time. Then you can see there is a course, or like a centralized data center, I would say, or the data center part, where we have the complete 5G core deployed there. Each core has their own functions, and we are dividing this into the NFVI. Okay, this is like the natural function, where we have the AMF, SMF, and these functions are will be using for the registering the user, analyzing the user, registering the user equipment, then the session management, connecting through a different data units. Then what happening is, we are having the external network. External network, basically either you want to use the internet, or maybe you are want to connect with other telco operators. So you can know, inside traditional technology like 3G to the 4G, we was having a signaling parameters, or we were having the signaling system like SS7 GTP diameter, which was allowing us to connecting with another operator. So what happened is, each operator was connecting to another operator using some IPX, using some STPs, and then they was using the signaling messages transformation between each of the component. So for example, how 5G is reducing the threat here, because they have introduced a separate encrypted traffic channel called SCPP, which is allow us to connect with another telco operator. And now the major advantage here, when we are going to send any interaction message or any messaging from another telco, it will first deliver to the SCPP interface, and then SCPP will decide which and a network function has to be communicated there. So it will increase more integration way of the new API based on the API, how the API is allowed. So for example, if I want to communicate with the function X, and based on this API parameter, the SCPP will only redirect with the function X, and then other component will not be disturbed. So now you can see how and why the latency requirement we need to be low there. For example, if we talk about the e-health system, you can see this graph basically, which is like reliability versus latency system, how reliability will be increased based on the latency. If we talk about the industry automations, we required a very low latency, which is like less than 0.5, and we need a very reliable system, because industrial automation is like, we have lots of the bigger machines, lots of the automatic robots, and all those things that need to be connect, that need to be get and perform the real-time action, and therefore we need a very small latency. It's depend. So major advantage of the 5G here is, here the latency is unpredictable, and based on the latency, what I can say, because each kind of the functions has their own latency requirement and in your own reliability requirement, and based on the reliability and latency, I can deploy a different slicing or different core, which will serve and fulfill my requirement. So here you can see, inside industry automations, we have again the latency will be low, but we can say the reliability will be more high. If we talk about the augmented reality or your metaverse or your VR part, you can see the latency requirement is low. Like latency can be less than 10, or even more than 10 is not, because metaverse is cyber, in augmented reality it will be reliable, but the latency is not too much high. But you can say, other than that, the reliability requirement is very tough. So based on the data rate we required, we can deploy a different grid. For example, inside the smart grid or EL system, the both latency and the reliability need to be high. But in other system, which is like for entertainment purpose, we can say that okay, our reliability will be little bit low is okay, but we need more latency. So these are the like latency and reliability requirement for each component upcoming industry, and this is where the 5G play a very big role to fulfill those different requirement with providing the higher security and availability features. So what 5G give you? Like, as you know that industry is going nowadays, because from the mechanical era to the full digital computer era, we have transferred there. The based on that one, our requirement has also increased. For example, we need a very high power of processing, which can like compute our processing power, which can provide a real-time informations and providing a more power. And you know nowadays the artificial intelligence is playing a very huge role, because this is designed to perform a task but without a human interaction. So therefore this 5G is creating a balance between like computing power and the connectivity. So based on the requirement, like you can have because initially when you see in the older technology like for industries or till 4G, we are using some wireless, or we are using the Bluetooth, we was using the LTE. But now since the 5G has come, 5G is designed to fulfill all the requirement in one time. For example, it can also deliver the information as fast as possible, like within a 1 millisecond or something, which can fulfill based on the old no reliability, which is latency ratio proportions. How the reliability and the latency is getting higher, we can compute this with the 5G on the real time. Like we can deploy different bots or different pods for this one. Okay, based on the like, it is also giving a capacity to handle a large and huge traffic, and the spectrum efficiency, because you don't need to utilize a full spectrum. Based on your requirement and based on the width, you can deploy. You can use a millimeter wave. So now it will give you more basic idea on this one, like how 5G is getting deployed, and like how 5G is playing a more efficient role, and what are the different deployment model here. So you can see that in our traditional technology, like from till 6 gigahertz, we were in our small cells, or like say till 1G to 4G, we was using like the micro cells, BTS, and small cells in like particular spectrum. But now here what happening is, like for example, the spectrum was totally dedicated. Like you was having your televisions, you are having your wireless, you was having your Wi-Fi, radios. So spectrum was fully divided based on the coverage and capacity, which is like existing mobile spectrum. And that purpose you need to deploy a different cell, or let's suppose you are using the hexagonal cell. But now since the 5G has come, okay, the spectrum will be fully dedicated from the 30 gigahertz to 100 gigahertz based on the requirement. And here we will use the small millimeter wave. This millimeter wave, you can see that the jitter or the length of the millimeter wave is very small, but they are going to be cover a small area with a very high frequency. So for example, if I want to cover a small area of the 1 kilometer, I can deploy a millimeter wave, or I can create a multiple micro small cells, which can serve a more devices or more component based on the requirement. So in a lesser area, you will get more and higher coverage. And this is the way how the spectrum is getting changed in the 5G as compared to the traditional technology. Because in till 4G, we was having a very big cells, and inside the big cells, we are serving the devices. But here, inside a small area, I will have multiple devices. So one devices to another devices, the latency will be low and speed will be very fast. So if we are going about the connectivity part, you can see that inside the 5G, we have two deployment models available right now. The one deployment model will be like we will use the existing infrastructure. Sorry. And another is the completely 5G SA. So one model is known as the non-standalone, and another is a standalone. Inside the standalone model, what we are going to use is totally a 5G model. So here what we have, we are using the 5G ANA, the 5G new radio inside the RAN part. Then we will use a dedicated 5G core, which we only providing the full 5G features. Correct? We are not going to use any of the legacy infrastructure. But another model, which is like the dual connectivity, because right now if you can see your phone, which is you are getting 5G, but indirectly this is not 5G. We are using the NSA model, where you are getting registered on a 4G, you are getting the 4G connectivity, then you are getting less to the 5G. So now what will be the advantage for using both the models? So for example, if I only need to use some specific functions, like suppose I have my IoT, I have my connected car, which is required a very high speed and very high performance, what I will use it, I can use a second model, yeah. based on the license requirement, and based on the requirement I can use the SA model. But in your phone, sometimes the requirement is little bit low. So what you can do, you can use it NSA model. Inside NSA model, what happening is I'm using my phone, then I'm using a legacy infrastructure of 4G, like I can use my E node B or a G node B, then I can use the 4G core. So you'll be getting a register inside a 4G core, and based on the device capability, you'll be latched to the 5G. Like you can just switch off your phone, and if you turn it on, you can see first you are getting the 4G, and based on the device, if your device is 5G supported, you will latch to the 5G. Okay, but inside the SA, it will be like more reliable. It will use the complete 5G core. You don't need to be add to the legacy infrastructure. Okay, it's like dual connectivity. So we'll use your 5G G node B and the 5G core, which is like completely 5G NR based on the 3GPP instructions. So here you can see that when I'm talking about the 5G core here, so here is my phone, this is my G node B for a 5G, and then I will be add to the, sorry, where's the laser pointer? So you can see that this is my phone, it will be latched to my 5G G node B, and then I will be latched to the 5G core. But now, since we are talking about the 5G core security feature in our main questions comes, what do you mean by the 5G core and what are the functions we have there? So if we go down, we can see that these are the 5G newly designed core, which is available here, and this core will help us to perform the different changes or perform the reversible changes inside of 5G. And this is the complete new core, because here we are not using the traditional signaling protocol like SS7 or diameter. It's fully IT based core. You can see each of the component inside the core will be communicated through a HTTP to or JSON API. More easy, more flexible, and similar like IT infrastructure. So let's talk about first part. This is called the 5G range. Just here inside the range you will have two parts. Yes, first thing which you have inside the range will be your user equipment, which is like your mobile device. You might be having your NB IoTs, you may be having your data card and all. Then you will be having your G node B or E node B. So if you are using the non-standalone, you will be having E node Bs and G node B, and if you are having the 5G core, the master device will be your G node B. Okay, now if we move next. So here are the different functions. So this was the part of the RAN, which is like UE and RAN part. And if we talk about the core has four main functions: AMF, SMF, UPF, AUSF, and NRF, or UDM. Sorry. So these are the main functions we have core. Apart from that, we have different network slicing functions, which is based on the requirement, based on the the feature. These functions are provided. So here how the questions come, like how the user equipment is getting registered here. So for example, these are like functions. So each functions, they have their own part, your own value. So if we talk about dine side, like if it's starting from user interface to the UPF and the data network, this is basically called your user plane where user activity is going on. So once the user is registered inside the core, he will basically connecting from the user interface to the UP and then data network. That is your user plane, and then you will have your control plane, which is performing the control part like AMF, SMF, AUSF, UDM. This will perform your control functions. And as you can see, so what will be the use for this one? The first thing we have inside the core part is basically a AMF. So AMF is known as the access and mobility functions. If you are familiar with your traditional infrastructure, it will be like same like MME or VLR. So it will be responsible and managing all the user authentications, user registrations, mobile connection management, everything be taken care by a AMF. So what happens is, once you, for example, I have my phone, I power on my phone, I put a SIM card. So basically you will register on a network through a AMF. So it will send a NAS signaling and then in ideal state it will connect to the AMF state. So what AMF will do, AMF will query the AUSF and ask for the authentication vector. AUSF will retrieve all the data from the UDM part, and then again it will send it to a UE part. And then once the use, since I'm not going to explain the complete authentication process here because it will be like more larger and take more time for explaining, just give you the brief idea. Request come from UE to AMF, then we'll go to the AUSF. AUSF will ask the request from UDM, and then the UE will be registered here. Once the UE will be registered here, let's suppose my mobile is registered, I'm not performing any operation. Then what happened? My idle mode, my user equipment will be connected through a AMF only. If I'm not connecting any operation, this is like idle connection. But let's suppose if I'm surfing or inserting, if I'm surfing a data or something, then I will be connecting through entry interface to a UPF, and then it will, this UPF will connect me to, for example, data network, or it will connect me through if I'm connecting a roaming call or something. This will be the task. Then we talk about next function that is called AUSF. So what is the part of purpose of AUSF? So AUSF basically your authentication server. So this is playing the same role like AUC you are having in a GSM part, which implement your EAP authentication. It will store your key. So whenever the AMF request the user authentication vector, it request will always go to the AUSF, and AUSF will ask the UDM to provide me the KC part. So it's like we can say AUSF is performing more and more of the authentication part. The next thing which is play, so main function of the 5G is UE, AMF, AUSF, then the SMF part. SMF play a very important role. It's just like your packet gateway inside LTE. So main part for the SMA is SMF is basically to establish and manage all the PDU sessions and allow you to, no, and allow your data services. Okay, and also it will also take some decisions with respect to the UPF traffic routing. Or in other hand, it will also allocate to the IP address. For example, like when you are getting the data, if you are assigned, if you enable your data channel, and if you check your mobile internal IP assigned to you, you will see you will get some internal IP, and this internal IP is always assigned by SMF to your phone. There are other functions which SMF also do, but I think this will be the different. Most probably, this is also useful for your lawful inspections also, where like the security agencies and lawful inspections is also taken care from the SMF part. Then the major part you will get is AUSF, AUSF will also
Okay. So, also one more thing, guys, the session, um, by the end of this session, we would be putting a quiz in the chat, and there will be total 20 MCQs, each of 2.5 points. And you will get a certificate for the same, and also the top scorers will get some exciting goodies
So
for this.
guys, give it your best, and you will be able to earn badges to keep your leaderboard positions. And at the end of each day, a scorecard will be available on our official Instagram, Discord server, and WhatsApp group.
Also, while in this time, we would also like to express our gratitude to our sponsors for their support. Starting with IMFS, our title sponsor. IMFS, founded in 1997, was the first institute in India to deliver expert coaching for examinations like GRE, GMAT, SAT, TOEFL, and PTE. The first institution in India to provide expert coaching for exams. And the next up is Aurora Coaching, who is our educational partner. The goal of Aurora Coaching, a crypto coaching firm, is to inform and raise knowledge about the world of cryptocurrencies among both individuals and organizations so that both can approach it with confidence.
And our streaming partner is StreamYard. On the StreamYard platform, you may broadcast over social networks directly from your browser before choosing the premium plans to gain access to more features. It provides a free option that you may test out. So, until the speakers return, if anyone has any doubts or questions related to 5G and IoT security, you can put it in the chat box.
Also, we will wait for some time since the sir has lost his network connectivity. Also, one more thing, guys. In today's day, we have covered introductory session for each and every track, MTT-S, CS, and IEEE. And tomorrow we will be having workshops based on the same topics that we cover today, so that you can apply the skills and skills you learned today into real practices. Okay, we have Sir's back. Okay, let's continue for further. Hello, sir. Am I audible?
Sir, actually, you aren't audible.
Hello.
Yes,
Yes,
sir.
sir.
Okay. Can you see screen now?
Yes, it's loading.
Yes, sir.
Yes.
So we'll resume with the session.
Okay. I'm really sorry for some connectivity issue. I think there was some connectivity issue from my side, but that's okay. So we was talking about the 5G functions here, I think. So let's continue from there. So you can see that these are the 5G internal architectures we have. We have couple of different main core functions and different network functions here. So if we talk about the core functions, this will be like your UE. Sorry, this will be starting from AMF, SMF, AUSF, UDM, and UPF. This will be your main function. You can say additional function is your PCF and AFF, but it is not in use right now. And there are the different network functions we are also having. That is your like NSSF, then you have NEF, and then PCF and UPF. So these are the network functions, and the main core component is a four part. So basically what happen is whenever I am starting with the registration, for example, when UE is here. Okay, for example, like I have my user equipment and he want to be registered there. So once I put a SIM card, the request will go to the AMF part. AMF will ask for the authentication vector. Okay, it will take from the AUSF. So I would say the AUSF is playing same role as AUC inside your uh, 2G part. Okay, which is like having the EFE authentication server, and it will store a key. It will send a request authentication vector, or I will say it will collect a request authentication vector from the UDM part and send it to the UE. So let's not go into the more deep detail of the UE registration process and attach, because it's like itself is a very big topic, but it's like in general overview. AMF, as I told you, is basically is known as the access and mobility functions. Most probably is like kind of your MME or a VLR, okay, which is like managing your user registrations, mobile connections, management, and all, and is responsible for handling the UE. So, like for example, if the UE is in ideal condition, is always connected to the AMF. And then third thing, which is playing the very important role, it's called the UPF. Okay, now UPF is known as the user plane function, and the any component you can see starting from UE, UPF, and DN, they are the part of the user plane functions, where the user is performing the function, and UPF is responsible, like it's kind of the PGW you have inside it's kind of the combination of the PGW or SGW inside your 4G. So it's like it's a point of interconnect between your data network, which is allow you to connect to a data network and performing the different routing part. Then the major functions which you have here is basically SMF part, is known as your session management function, which is play very important role, kind of the P gateway. Is basically helpful for establishing user sessions with to access the data services, and also it will also select the route for the UPF traffic selection. In other hand, there is a major use of the SPF, which is like mostly for the allocating the IP address to your UE. Like you can see when you open a termX on any of the phone command, and when you see, you will get some IP addresses there. This IP address basically allowed from the SMF site, as well as what will happen if there is it will also useful for lawful inspections. So if we move next, so now we are talking more about the like no how the security requirements and the 5G is playing a huge role. For example, you was having a inside a traditional infrastructure. Let's suppose you have UE or you have NB-IoTs, you have car or connected or a different component. They was connecting through one radio network, and this radio network was connecting through your 5G, sorry, the traditional core and the data network. But as you can see that each of these equipment or user equipment has a different requirement. As we show initially, the reliability was this versus a latency graph. Based on that, like each kind of the industry has a different requirement. For example, if we talk about the user equipment, no, which required like ultra high bandwidth. For example, if you are using the metaverse VR, or if you are watching UHD videos, like you require more speed, but latency can be 10 ms and less will be okay. But if we talk about the NB-IoT, which has like low power but very high density, okay, like for example inside one G node B you will add maximum to maximum device, and the reliability requirement is high. Here if you talk about the user equipment, reliability requirement is a little bit low. Same way if you're talking about the V2X solutions or the vertical car, or let's suppose connected car solutions, you required very ultra low latency, but you required very high reliability. And so overcome this kind of a situation based on the no QoS, like based on the reliability and a requirement as well. So reliability versus latency part, we have 5G's introduced a very cool function which is like very helpful, which is known as a slicing part. So this slicing part is like playing a very crucial role. What happen is, based on a purpose. For example, if my purpose is to handle NB-IoT, if my purpose is to handle the V2X requirement, we have introduced, we will create a different slice of code. So if you can see in previous slide, we have defined core architecture. This core architecture basically shows what are the component involved and what are the network functions involved there. And based on the user requirement or based on the serving requirement, for example, uh, let's suppose we have some component there, and this only required a two component, like they only need to be registered on ID register AMF, and they only need to connect with the SMF part. So based on this one, what I have created, we have created slicing. This slicing will be like deployment of the each core component for the different purpose, and that way it will provide a more security. For example, one of the component got compromised, also other two components still functioning, or if the user make any kind of DOS attacks and all, they still do function is working there. So it's like more on slicing part. So let's move, because I think we have very small time. Okay. One of the major biggest feature also the 5G has include, which we have seen in the last slide. This is called MEC. Sorry. Okay. Now, this MEC is also basically used to fulfill a requirement for a NB-IoTs. Okay. Now, so first question, like what the MEC? MEC is basically known as the multi-access edge computing. Okay. This is providing the different computing solutions. For example, if I want to deploy some SIM-based camera, okay. So what happened? I don't need to connect to the whole core platforms and going to the perfect route. I will create a MEC application which will handle my MEC data and the required required core function which will deal with them. So this way, what happened? We are reducing the latency as well as we are reducing the cost. And let's suppose I will create a different MEC architecture or MEC application. So this MEC application, what happened? They will host my app. For example, one app which will only help me to connect my connected vehicles. One app will be only helpful for connecting a different, let's suppose, camera department. One of will be for the IoT purpose. And this MEC IP will be exposed to the respective MEC services. and then it will connecting to my core network. So if in other way, I'm using the slicing and MEC to reduce the speed and providing the higher data rate. So let's go next, because again, so now if we divided 5G, so basically what are the capability or what are the things 5G is providing to us? The first thing is basically 5G is providing a very new trust model. As I told you, discuss about the slicing and MEC, which is a new feature which is in initially, if we talk about 4G, this MEC was to be considered as NB-IoT, but now in 5G we have full-fledged MEC available. So it's like new trust model we have, where we have slicing, where we have MECs, we have NFVI and different network functions there. We have completely new service delivery model here. And now what happened is, the main feature we have the spectrum efficiency. So if the spectrum is efficient, the cost of we have very cost efficient. For example, like initially you was dependent upon the vendors. Like for example, you have Huawei, you have Nokia, Ericsson's. Those vendors, they are selling their own equipment. So you'll be need to be depend upon those vendors, need to buy a very bulky and costly equipment for them, and then you have to build your telecom infrastructure. But now it's more easy. If I was just checking yesterday, Amazon has also no set up his own private 5G, and it's already launched in the market. So you don't need any bulky equipment. You can create and find a different component from different vendor. You can integrate them and you can launch your own solutions there. Okay, then as you can see, inside of 5G, our control and radio unit is no distributed, like they are splitted. So you can buy a CU from some other vendor, DU from another vendor, and you can combine them. This is like known as your open range solutions. Okay, and then you have different function variation based on the requirement. And one more advantage what we have is like a API based, because each of them is will be a API based solution. Yeah, so you have different APIs for the connectivity, where you can connect your different functions. You can also no borrow, you can also host different function based on the requirement. So this is where the 5G is basically in inbuilt security is giving, as well as for the automation purpose. You can deploy one pod, like you can deploy one Kubernetes pod, and you can create a full automation on this one. For example, one pod is down due to some malicious activity. This pod will automatically shut down and restart or destroy the older pod, and the new pod will be created there. So if we talk about the security features, the main thing, the main component which will need to be taken care inside a 5G is basically a mobile device. This is like end user component. Then second, your private MEC. Third is the public MEC and the regional data centers. So these are the main four components which we need to be taken care inside a 5G. For example, your end user device, which might be your cars, it might be your physical infrastructure, mobile devices, it might be your NB-IoT devices, it can be a camera, which is like this is the main attacking vector you have inside of 5G. Then a private MEC. So basically, as we introduce the slicing functions based on the NFPA and SDN part, there might be possibility that one slicing can also be communicated with another slicing based on the requirement, and there are lots of the attack vector which is getting exposed there. If this is public MEC, we need to be taken care of mostly like the expose MEC expose API to the public internet, because an attacker can get those API and try to exploit it. This is a reference, I took it from somewhere. But as you can see, the more advanced feature in 5G, what happened is like this concept of the IMG is totally gone, and they have introduced a new function called SUKI and SUPI here. So if you see inside a 2G, the interception was like local, and local interception was easy, as well as remote interception was more easy. If you see impersonation and DOS attack, everything is busy because of the SS7 attacks. And same in the 3G was. But 3G, what happened is inside a local interception, what they have introduced the mutual authentication, which has reduced the risk of local interception. But yes, again there was SS7, and due to that, people was able to perform the remote interceptions or impersonation attack. When the 4G has come, of course, the attack surface has reduced and diameter protocol was there, but still there was a possibility for remote interception, as well as there was high possibility for DOS attack. Now, inside of 5G, the concept of the transmission of the IMG is gone, because they are converting and using the new concept called SOKI and SOPI here. So here the interception part is totally closed. Either is a remote and local, because this has new SCPP APIs, which is still into the consideration, because the 5G roaming is not full-fledged ready right now. So the risk of interception is totally eliminated there. List of the impersonation is totally eliminated, because everything is API based communication, and as well as each slicing based communication based on the network functions. Now still there is a possibility of the DOS part, but this there is a new release going to become for mitigating those issues. But yeah, there is a risk is very less for a remote and local DOS. Still there is a way you can perform a user DOS, but remote DOS the probability of the remote DOS still is reduced too much. So What are this is another feature, as I told, like they have different security standard specification, because as I told you that you are going to be have a distributed component, like you can have open range solutions, you can have different MEC solutions, and you can deploy different slicing solutions. So what you can do based on the requirement and standard, and the country and regulatory requirement, you can purchase those equipment based on your. Then you can have DevSecOps or secure product development approach, where you will use this no CI/CD pipelines to design those components. Then you can also what you can do is, then you can also create a secure network design and configuration deployment for this. So these are the security features we have there. So now let's go with the evaluation part, how the 5G is coming here. So initially the main thing when the 1G was introduced is long back, okay. So main thing what the 1G has done is 1G has removed the cord from your cable, and now you got your first wireless phone. This is the way, but of course the this is like the time when we was the technology of the telecom was just getting designed, and there is a starting phase of the revolutions where like you remove the cords. Then the second time the things come is like the 2G part, which introduced a very good things, is called M2M and machine to machine communication, okay. And this also increased the speed for a phone, and we was getting some 64 kbps, and we was this is getting started. Like you got the MMS, you got the digital voice communication. Then the 3G was introduced after 1998, and then this 3G give you the more power, the speed got increased, as well as no, you was having the web browser based communication. You started the thinking about the IoTs and all those, and then after 2008 we got the more faster speed, that is like 4G. We got almost like 100 mbps speed, where we was having the live streaming, remote sessions, connecting the IoT devices and all. And after that what we have done is we got a new one, like after 2022 the 5G is introduced or make it publicly, where we have very low latency and we can achieve a very good high internet speed, and it's like more faster than a 4G, which is like helpful for achieving and performing the real time task and real time applications. So we can say that inside the 4G there are the couple of the security features also involved there, and this feature basically help us to secure our communication, because that once the 5G is designed, and as you know that the technologies grow, the couple of the threat surface and attack surface is getting increased there, which might lead to the some kind of the compromisation of the network and attack or create some harmful impact. And now after 5G, of course, we are going to move towards the 6G part, which is like more faster than a 5G. So as we told, a couple of the security features, for example, like slicing, and we talk about the open RAN, we talk about the MEC, but there are a couple of the attack also involved inside the 5G, which can also be included. Like for example, they may be having the attack related to a slicing part. They may be having some attack related to NFVI, because these are the future. These are the feature introduced in a 5G, but there are some attacks there, like security gateway attacks will be there, some IoT attacks will be there as end user part. They may be having some backhaul attack. So just to overcome these attacks, there was a couple of no, the countermeasure has been taken care from the 5G, which is like basically EU security method is the end user security, where like you need to taken care of the malware, side channel, and zombie attacks. And access network security, as I told you, like the air interface security, the local and remote interception is almost no very low risk of the local and remote interception, but still yes. Inside that you have the MEC related attack will be there. So what you have to, as we mentioned earlier, we need to be focused on the more or secure development and robust network design here. So apart from the MEC, you will have issue related to supply chains. You will be having the issue related to your cloud deployment. Then if you talk about the core, there will be two issues will be there. Either the security related to your service bus architecture, or a slicing, or maybe exposure of a network component towards public internet. When we talk about the service application, these are the very less attack. But in generic security, because at the end it's a traditional IT system, you are going to use APIs, you are going to use JSON, so there will be the OWASP top 10 attack, which will be also applicable for that. So these are like security features and respective attacks is available on a 5G. So if we talk about, so let's more focus on the IoT part. So basically, as you know that IoT is basically an electronic device which has some physical controllers, sensors, and actuator. Inside 4G, when 5G, we are going to be use a concept called NB-IoT, is like known as the narrowband IoT, which is like fulfilling the requirement for from telecom point of view, because like you can see, you will have the smart metering. Before that, there was used to be analog meters at home. people are used to come and read those readings. But now we have complete digital meters, and this digital meter can be taken care and to be understand. No, the readings can be taken care remotely. They are sending the real time data. So those like inside NB-IoTs, you will have the NB-IoT sensors, you will have a controller and a backend API which is sending those data. This NB-IoT can be also used into agricultural environment just to detect any kind of the harm to the no existing pesticide or something. You can have the smart building where you have those PLC systems and all. You will have the smart city where like you don't need to control all the street light, or you don't need to be do because everything will be taken care smartly. Like you will have a centralized system where system solutions where like you all the smart lights or your parking management system your waste management system will be connecting through a different sensors, and those sensors will send the data on the real time, and these data will be read and the respective action will be taken care. Now on the other hand, like how we are going smart, we are using the other couple of things, like we are using the Alexa, Samsung TVs in our general home. This is part of the ongoing IoT system. So how 5G will play a role here basically. So you can see there was a like four revolution has come here. The initial revolution come for the mechanization, because initially we were totally handmade. We were using the physical machines and to handwork or like handmade stuff was there. And then the revolution has come, and this revolution is moved towards the electrical part, because lots of the machines has come, your task will be more efficient and your workload will be done. And then the third revolution was come into the industry is called digitizations, where like people was moving from the traditional paper based work to the digital industries. Then the fourth revolution will come is like basically a connectivity, where like you are connecting the more no reliable component or smart component into your production environment. And then the fourth revolution basically wireless evolution, where you are using the wireless technology like 5G, and you are connecting all your connected component machines and everything to be get data and do a more smart work. Like all work will be taken care by a machine here. Okay, so in the fourth revolution, if we say the industrial revolution, basically what happened is like in first revolution, what the factory will be reconfigured there. Then you will have the mobile robot, artificial intelligence there, and this will taken care of your day-to-day task. So you can see like inside the fourth revolution, for example, if we talk about the industries part, you can see all the gas meters as we discussed initially, or your water meter is got smart, and now there is a smart grid will be there. So you don't need to be taken care of everything. You will have one meter and automatically you are getting bills at home. You are having the smart city where you have the ring of no collection of the mesh network, and all the smart city like they are connecting to a smart grid. Like electricity will be managed efficiently based on the requirement. The power light, street light will be turned on, street light will be turned off. Okay, if the user is there or some person is moving there, the light will be automatically turned off, then it will be automatically turned off. If we talk about same revolution, this is also come inside your logistic industries. So those are the revolution has been come towards the no the IT due to the IT and electronics industry. Those are revolution has been come there, and this is going on right now because you are having all those smart meters and all. But what will be the more? The future will be like a more future will be going to be more revolution, because we need a faster response. Your complete factory will be automated. I think after some time you don't need a human to be go to the factory or a distribution unit. Everything will be taken care by robots. You just need to give some real-time commands and it will be taken care. You don't need a driver. Initially you can see there was lots of the requirement, and the old car was there, and too much people used to be hire a driver. Then the revolution come and we start driving our own car. And the next revolution you don't need to drive anything, because it will be again taken care by what is it, artificial intelligence, and this intelligence will be taken care or controlled remotely just by sending some real-time commands. Inside like attack surface, as we told, we have take couple of the industries like industries, transportation and IoT based. So attack surface for IoT, basically what happening is we have different sector, for example smart grid, transportation, retail and healthcare. And inside we have different IoT devices. Okay, like some, for example, you will have your energy generator inside smart grid. You have a turbines, windmills. Okay, if we talk about the transportations, you will have vehicles, ships, you will have your parking meters, all those. So these are the like surfaces we have there, which are like different sector and devices role with there. And based on those roles, there will be attack surfaces. As we told in 5G, couple of the feature include, but they also have some attack surfaces. Those attack surface inside IoT basically area where people can try to penetrate and gain access or perform a harmful action for the IoT devices. For example, if we talk about the energy generators, or we talk about big turbines, they are fully smart grids, and this smart grid is controlled by a centralized management system. So based on those, for example, if you talk about the attack surfaces in economic, if some of the smart grid, they have the exposed APIs there, or let's suppose they have one terminal which is not secure, or let's suppose they have one of the OT system which is also connecting the same camera and this OT devices into a similar network, and somebody who has access to a one network, he can also try to compromise those smart grid even. So the attack surfaces include basically your ecosystems, device memory, because in IoT devices you will have their own memories, they will have their own firmware there. They will also have a web interface. So if I design IoT, I'm connecting those IoT connectors into my web interface, and my web interface is not much secure. Let's suppose it's vulnerable with OWASP top 10 vulnerability, one of the VPAs. So what I can do, I can access this physical web interface, and using that interface, I can stop the real-time data sending from the IoT devices. Or what I can do, I can try to stop the grid itself, or I can know trying to manipulate the data from the IoT devices. So these are like, I can know different actions will be performed based on the attack surface available for this one. Let's talk example, for example, for the consumer home or the smart home devices. As you can see, we are putting the Google or Alexa with we are connecting each of our equipment, home equipment like light services, the electric services with Alexa. And now you can see tomorrow someone who can just create one ultrasound code and send it to your WhatsApp, which where you cannot hear it, but the ultrasound code just contain the message like, Alexa, please shut down all the system. And once you play this message, you cannot hear because you cannot understand the ultrasound code, but it automatically Alexa will shut down it. So this is a very small attack surfaces. Or if other hand, I can say that, let's suppose you are using Amazon Alexa, which is connecting your home, which is connecting your smart TV, and one of the TV has some API which is basically connecting your Alexa, and this API is not secure. So if you are having access to those API, you can again send a command to Alexa and perform any unauthentication access inside your smart home. So those attack surfaces getting increased. So for example, this is like one of the slide I took it from the GSMA. So if you talk about the smart city, so these are the IoT challenges what we are facing for the smart city, and different attack surface and security features will be there. For example, inside the smart city, if you can see, there is a car. So what are the attack surfaces for car can be there? Okay, the first threat for car will be like, it cannot recognize the sensors, or let's suppose the ALU of the car is like exposed, or let's suppose you have the connected APIs which is using some this car has some SIM card and is using some MEC feature. This API is exposed there, and somebody gets unauthorized access to this car, and it will like try to crash the car. Or let's suppose the sensor got failure and car is not able to understand the transmission or the safe distance between two car. Okay, so these are the attack. Or let's suppose I just give a command to the sensor that, okay, don't stop on a signal, so car will not stop on a signal, it might again can hit another car. Same way, there is a supply chain for a car. Let's suppose you have your firmware which is installed inside a car, and we found that this firmware is not secure, and there is some exposed hard-coded key is there, and using that you can, or the radio interface, or let's suppose RF channel will be there, like you can just, there is a key replay attack will be there. So if there is a driverless car, and this driverless car, what happened, my, let's suppose my 5G SIM card is inserted inside a card which is connecting to a command and control center. But what I can do is, inside a real time, I will try to create a DOS, because you can see there is still a possibility inside a 5G. I create a DOS for a car, and this system is not able to send a real time signal. And that way, the car will not understand, either the car will shut down or it might be hit someone. So this is like another attack surface I have. Or what you can do is, somebody who is just like, suppose you using the smart car, you are parking somewhere with a smart charging grid, and this charging grid, somebody get the unauthorized access to this one, and then maybe send some different command for this one. So there are a couple of the security measures they have also include. For example, if you see, they have include like identification and authorization. They have used encryption mechanism for this one. Okay, they have also used the different car OEM vendor security, because each OEM installed in a car should be totally no patch, and there should be proper authentication should be there. Each OEM should be different. I cannot use different OEM keys for that one. So these are way like I can. There are the challenges still there for the smart city with IoT, but yes, we are trying to solve it out. So you can see how, like, for example, if we talk about the different oil grid system, or let's suppose the initial industries, how industry basically working there. So in industry 3.0, you can see there was some machinery has include inside the machinery. You was having your controller systems. Then this controller was connecting through your industrial internet system, and then they are controlling all the system. But what happen is I have access and attacking one of the grid, or let's suppose one of the switch is vulnerable, and I try to perform the starvation attack, or let's suppose I try to perform the MIT attack in between, and then I can control whole no system. Here what happen is, like, I can create a 5G small cell. So I will have one deploy core or basically network slicing based on the requirement. I will create a slice of the core network. Inside the core network, I will deploy a small cell, and this small cell basically will be having the NB-IoT system, and this NB-IoT system will controlling my complete industry operations. So if one of the grid even also got compromised, the attack will be stopped. Here you are not going to penetrate, and no, you are not going to penetrate, or you are not going to impacting the other operations. But if you see the traditional infrastructure, one of the component got compromised, you can compromise the whole infrastructure. This is how 5G small cell will also play a role, because no, based on the slicing functions, they are creating those grid, and this grid will be separated. Basically they are doing the communication on the API, and this API is basically the communication which is allow for specific operation. Let's suppose you are allowing all the equipment to be connect together through the small cell. They are not connecting to each other directly, first of all, and in small cell you only allow the specific set of API to perform the certain action, not everything. So, so now like suppose when we're talking about 5G, we identify IoTs and their respective attack surfaces. So how to secure those systems? So as you know that we have virtualization security, we need to be involved the slicing security and the cloud native web security, because you are deploying everything on the cloud as well as the pod. So you need to be taken care of all this part. So first of all, for the securing the 5G, you need to understand, let's suppose you are deploying the 5G network for a customer. So you need to understand first of all their day-to-day operations and the security requirement for this one, and then you need to understand what are the functions you are going to be deploy for a customer, because you are not going to deploy a whole core. Or if you are going to deploy a whole core, you need to see number of the API connection which will allow with their each API slicing, or let's suppose one slice should not able to access another slice communication. Then inside the MEC, you need to understand that you should not expose anything to the public, as well as this MEC connection. Suppose if I connecting one of the MEC API, they should not allow me to connect with another core component. Yep. Inside other that, like you need to taken care of your endpoint security, which is like mostly user responsibility. Like for example, we talk about the smart car or a connected car. So in connected car, the manufacturer of the car, they need to taken care of their own security system before connecting it. This will be like the economical chart, how the 5G will impact the IoT system, and this is the how the revolution, because you can see that the economy is going by 2025 to the 13.2 trillion, which will be like inside agriculture department, construction department, everywhere, like how the IoT will play a role. But the question comes, how IoT will impact us. So you can see this is the market data which is we are having, like IoT is going to use inside agriculture, retail, finance, and all those systems. And you can see the major area of IoT will be your e-commerce. So now you can see how you are doing it. Like you are going to the Flipkart, you are buying it, or let's suppose any e-commerce site, you are going and buying it. But now once the 5G is involved with the real time in transformation, what you can do, you can try this particular stuff yourself. Let's suppose you are buying, you are purchasing one dress. You don't need to be go to the shop, man. You can directly use a tablet. You can just try it, how it will look on you, how it will feel on you, and they will use artificial intelligence and data analysis. And once you will try to just put a sketch, it will show you how this will suit you, what will the user opinion there based on your social media connectivity, and it will collect all the data and give you the clear picture on this one. Then you will have autonomous driver, like you don't need a driver for this one. Your car will be automatically connected, so you can do this, use this time for doing something else. There will be flexible manufacturing, and the more advanced feature will be like this private this what we say inside the 5G rain part. You will use these NB-IoT sensors for the agriculture, and this agriculture will really help you for determining okay, these are the particular things which is going to be destroyed, and these are the pesticide you need to be use it. Okay, there is insect we have detected there. So this will play. You can also use the inside a smart logistic, how it will play a role. For example, like you can see nowadays different hoardings and different big information there. But now in logistic, what happened, it will automatically send information to you. Okay, after 300 meters there was accident happen, after 300 meters this is the information, or you need to be slow down your speed to this one. Like you can see the Google map, but Google map is not that efficient till now. How 5G will give you the real time data. Okay, after 200 meter you need to be slowed down, or after 200 you need to press a brake, which is a particular force of Newton, you need to push this brake. So those informations will be available, and this is how this will change this one. Like you can have a drone delivery, like during this COVID lockdown, you can see people was using drone for delivering this stuff. But still you can see nowadays we have the delivery guys from the Amazon, Flipkart, Zomatos, they are delivering this stuff. But okay, in the upcoming days it's going to be more IoT and drone based. You just order stuff and you can see within a 5 minutes the drone will be there and it will deliver this stuff outside your home. You don't need any human, so it's like more going to be reduce the human effort and going to be more smart and artificial intelligence based. So like you can see, the IoT basically is divided inside this one into the three parts. Well, with the consumer IoT, enterprise IoT, and industrial IoT. So as I told, the consumer IoT is basically going to be your home management, smart mode, smart grid, smart solutions there, where like no, like the Alexa is, we can say that is part of the consumer IoT because we don't need to, we just need to send a command and Alexa is its own no action. Then we have going to be use the enterprise IoT, where like we have fleet management, asset tracking. For example, in a real time, you are having a car which is going to be deliver some cash, or let's suppose going to deliver something to the point A to B. Now inside this one you will have some NB-IoT point, and endpoint of the NB-IoT you will put a SIM card. What it will do, it will real time do a tracking. So we'll define a path from A to B, say that this is a path from A to B, this is the speed you need to maintain, this is what you have to do, and this will be fully controlled there. And then it will send a real-time location of the car in every 10 seconds or every 1 minute, depend upon the requirement. So we'll do a real-time asset tracking and the fleet management. So it will there will be very less chances of, let's suppose, less chances of losing your important stuff, or there is less chances of robberies or something, because you are already predefining everything and you are real-time tracking everything. This inside the industrial IoT, as I told, as I show you earlier, yes, like once you have a 5G and different MEC services, you can totally automate those services. Will put your 5G grid, and then you can control each of the solution based on the slicing requirement what you are putting on there. So so like if you can see how the 5G like playing the role for this one, like if you use the enterprise use case, so it will provide high bandwidth and a very good QoS for this one, because like you need to perform a real time tracking for the industrial component, as well as based on the slicing. Basically it will based on the function, you will have the different slicing for the 5G. It will also introduce, so these are the like use cases we can build up for a particular organizations. And then how the what happen is, we need to be clear. So it's like this is like value of the IoT and 5G. So let's suppose you have slicing functions. Inside the slicing function you will have a different kind of use and requirement for the slicing. So here what happening is, there will be the two trust model will come. There will be the requirement which will come from the MNO side, like they need to sign the perfect SLA for a slicing, because MNO is the one who is going to be provide the slicing option. And there will be the crowd relation between car and telecom manufacturer. Why there? Because as I told you, yes, because let's suppose you have a one telecom solutions for 5G SIM card or NB-IoT module inside a car, and there is a car firmware or the OEM. If your OEM is vulnerable, that does not make sense, because people can access your car using the OEM. Or other way, let's suppose you have very good OEM, but the MEC is exposed from the car side. So someone who has access to this MEC can also take control of this one. So there will be the close relation of the SLA will be there. So for each industries, like we are going to be find out the particular controls and what are the requirement need to be performed from the MNO side. For example, if we are going to use for industrial IoTs, or let's suppose if we are going to use for a wearable technology. So no for example, we need to use the low cost services for them, like how the costing will be impacted, because at the end costing should need to be designed, and that will be taken care by the user. So I think that's all for now, because we have lack of time also, and this is finished from my side. So
Thank you, sir, so much for this insightful session. And I'm sure that the audience must have gained a great deal of understanding of all the subjects covered today. Well, now we want everyone in the audience to put down any questions or doubts they may have in the comment section. Okay, you can put down your questions in the comment section.
So I can see a number of doubts and questions in the comment box. We'll start one by one. So the first question is from Pratik. How long will 5G last till 6G catches up?
Okay, so Parthik, I want to highlight in this way the 5G will not be the last because 5G is just a starting phase of the revolution. And as I told that 6G is still is under development. There is no the parameter. There is no particular definition has been designed for 6G yet because still we are not full fledged ready with the 5G. It's lots of take. It will take still 2025 for us to become to be make a full fledged 5G ready because no inside the telecom industries is not about the having the 5G and you are getting the high data rate. You need to be have a real time services need to be available as well as you need to be have a calling services. You need to be have a roaming services. So once the 5G is fully ready, then we can define that okay, we are ready to go with the 6G right now because still is under definition is under development. But yeah, I would like to say one point that will be going to be 50 to 60 times more faster than the 5G, but the ending time is not it fixed now because we are not even full fledged ready with 5G even because I think recently in India it's just like 2 or 3 days before the 5G spectrum has been sold out. So all the companies, and if you're getting the 5G inside your phone, is I'm trying to tell you, you're not even getting the 5G. Still, it's 4G only. It's just they are showing as a 5G. Okay, because like 5G SA, lots of the company inside India they are still doing the R&D and experiment to be full-fledged 5G SA ready, and then we can think that how long it will take because there will be some certain facts available on internet, but this is not exactly true because you need to be have fixed definition for that.
So, can you please turn on your camera for the question and answer session?
Okay. Mm. Yep.
Yes, thank you, sir. So the next question is, should a service provider now plan to start a 4G deployment or hold off until 5G?
But 4G deployment is already there, so I did not get the question.
So the question is like, should a service provider
Okay, I see
now
this.
planning?
Yeah, this one. Yeah.
Yeah.
So when you say 4G deployment hold off until 5G, it cannot be taken care because see, I tell you, first of all, what happening is somebody's typing something. Okay, so
It's
basically what
fine.
happened is right now there is a discussions going on. Some of the country who has already shut down their 2G and 3G legacy deployment because still you need a 4G because some of the features from the 4G, for example, this VoLTE interface which is using for a calling feature, yeah, the 4G will be the backbone. It will be continue. It will not going to stop their deployment. Only the legacy technology till like 3G and a 2G will be going to stop. But some of the country who has already stopped it, some of the country which is still planned but they didn't decide it yet. Apart from that, 4G deployment will not stop here.
Okay, sir.
Okay.
So on to our next question. So it is from Soumya that I keep hearing that 5G will require millions of small cells. Why is that?
Hello.
Yes, sir.
Yes, sir.
Can you hear me?
Yes,
Yes,
sir.
sir.
Because I turn on my camera, why it's not showing me? Okay, so let me tell you in this way. So when we talk about the small cell, okay, now right now you can see the big towers for a 4G. Yes, these are serving the 4G. Now in 5G, what will happen is let me share one screen if I have somewhere. So it will like no very small power radio cells. The power will be very small, and let's suppose they are like put it into the 10-meter ranges inside a few kilometer. For example, let's suppose inside the 1 kilometer you will have number of 5 to 6 small radio cells which power is low but they are more into the higher bandwidth.
Okay, sir.
So why they are deploying it, for example, because you want to serve lots of people. So inside the 5G, inside the one cell, the requirement is low because like I have to give you higher bandwidth, then I cannot serve everyone in a one time. Okay, just to serve multiple user, I can just increase my capacity. Let's understand into this way. Let's suppose you are having a one faculty who is able to taken care of 10 students, and there is a one faculty who is able to taken care of 50 students. So what happens is one faculty who is taken care of 50 students, he will provide information to every 50, but not every 50 student will get all the information at a time. But if I reduce it, one faculty per 10 student, then you will get the more information, you will understand much better. In the same way, if I want to serve a device and I want to provide very high speed and very high very low latency and reliability, what I will do, I will create a small cell in the sense like small radio network which can serve, let's suppose, x number of the phone, x number of the component at a time. And if the number of component will be increased from x plus 1, it will go to the another cell. In that way I can constantly make my speed and the same speed for each system.
Okay. So then next question is from Kirti. How will 5G latency be lower if processing is being done in the cloud?
Okay. So when we say in the cloud, see, there is something called a telecom cloud. Okay. So now, for example, if I deploy one Kubernetes pod for there, and this pod basically what happened, like in general when we are putting a Windows, you have your desktop at home. If you're starting desktop, it is starting, and if you're deploying one virtual machine inside a desktop, it will taking a time. But what I'm doing is now I'm using the cloud interface. Inside the cloud interface, I'm deploying a small pod for a function. So based on the function, they are very faster. Even let's suppose one cloud is shut down or is overloaded, automatically what happen? It will enhance the capacity and the second cloud or second instances will be created and the user will be handled there. And this is the way no we are using the low latency. It means like speed is faster because like I have multiple component in a very small cell and they are taking very less resources. So the processing time for the resources will be very low here.
Okay, sir.
Okay, sir.
Uh, any further?
Okay, so
Okay.
that's the end of the Q&A session. That was really great, and I hope that all the doubts were clear. So thank you, sir, for this incredible session and addressing and educating the attendees with this informative discussion. And we are very grateful to you, sir. So for that, we would like to present you with a token of gratitude.
Thank you guys. Thanks for opportunity.
Okay, guys.
So I think you guys will have your Q&A round, and unfortunately, I have to leave now. So thanks again for giving the opportunity. It will be really nice to giving and sharing this knowledge on 5G, and really nice to meet with everyone. Thank you.
Thank you, sir, for being a part of Epsilon 2022. Thank you.
Thank you, sir. Have a great day.
Thank you. Bye.
Bye, sir. So, guys, buckle up because it's the time for quiz. You have 10 minutes to complete this quiz, the link for which is available in the YouTube live chat box. Give your best, and you will be able to earn badges to keep your leaderboard position, as we said earlier.
And before we begin, I would want to take this time to explain the point system to you. This quiz will consist of 20 multiple choice questions for 2.5 points or 5 points each. At the end of each day, a scorecard will be available on our official Instagram account, Discord server, and WhatsApp group. So, thank you for being such a great audience. And to get your input, we have included a link to the feedback form in the chat box for all three sessions conducted today. Also, to maintain your place on the leaderboard, do join tomorrow for a fantastic hands on workshop experience in the field of blockchain security, cybersecurity, 5G, and IoT security.
With that, we have come to an end for day one of Epsilon 2022. Hope you guys enjoyed and learned a lot today. Also, we wish you all the best for your future endeavors. Thank you, guys.
Thank you guys. Have a great day ahead. Bye.